All right, today we're going to continue discussion on how to solve a system of equations, but we're going to use a method called substitution. The other day we looked at graphing these to get an answer, and today we're going to actually solve them algebraically. So I want to talk about the first part here, substituting into solving a system by substitution. We are going to substitute into an expression. So we are going to use this method if you already have a variable isolated or one is easy to isolate. I want to remind you of this table or graphic you have in your notes from the other day. 3 different ways we can answer these. The first way is if there is one solution, and so what we did is we went ahead and discovered the other day that wherever they intersect is going to be your solution. So today when we solve these algebraically, if we get a number for x and a number for y, we're going to go ahead and write it as an ordered pair. Another way would be if there's no solution. So if 2 lines are parallel, we did a no solution. Today what it's going to look like is we're going to end up solving out and getting something that says like 0 equals 3. Or basically 2 numbers are not equal. We'll call that no solution. The other day, when we had one line graph over the top of the other, we called it infinitely many solutions. Today, algebraically, we'll get the same number equal to itself. So we'll see some of these examples as we work. All right, example 1. We're going to solve the system by substitution. Remember, solutions are the intersection of 2 lines. So write them as an ordered pair. We're going to write no solution or infinitely many solutions if we need to. Now, when I look at this example, I see that y is isolated. So wherever I see a y in the second problem, I can substitute x plus 8 in for y because they're equivalent. So when I go to write out the second problem, I'm going to have x plus, and I'm going to plug in the value of y, and then rewrite the rest of the equation. So all I did is substitute x plus 8 in place of y. Now remember, there's just an imaginary 1 out here. So if I go to distribute, I'm really not going to have any changes in my answer. So I can rewrite this without parentheses. So x plus 8 equals 2. And now I'm just going to solve like I normally do. Combine like terms. So x plus x is 2x. Then I can move the 8 over. So take away 8 from both sides. So I get 2x equals a negative 6, and then divide off your 2. So x equals 3, negative 3. So I actually have half of my answer. So I'm going to write my answer as an ordered pair, and I know that I'm getting negative 3 for the x coordinate. So I can take that answer, and I'm going to substitute it back in place of x in the first equation. So when I go to write that out, I'm going to have y equals, so plug in the x, negative 3 plus 8. And now we can just do the math, and we'll have our answer. So y, negative 3 plus 8 is 5. So the second part of my ordered pair is 5. So negative 3, 5 is the solution. So we solve for 1, plug it in, and then replace that in the other equation. All right, number 2. Same starting point. Solve by substitution. First equation has x isolated. Wherever I see an x, I'm going to plug this expression in. So I'm going to plug it in place of x below. So my equation will read 2y minus, substitute in x, 2y plus 1, and then write the rest of the problem down. So remember, there is a 1 in front of this, and this time it's a negative 1. So I am going to have to distribute that negative 1 into my parentheses. So I am going to start with 2y, and then distribute. So negative 1 times 2y makes it a negative 2y. Negative 1 times 1 makes it a negative 1. Okay, so now combine like terms. 2y minus 2y, that's 0. So I really have 0 minus 1 equals 3, but that's just the same as negative 1 equals 3. Now that doesn't make sense because negative 1 and 3 are not the same. So this will lead to my no solution. So I would go ahead and finish the problem out, and we would call this no solution. Okay. The other day on the graph, these would have made parallel lines because they wouldn't have intersected. Okay, moving on to number 3. If you feel like you're ready to pause the video and try one on your own, then I would do that. When you're done with the problem, replay the video and see if you got it correct. Okay, number 3. I see that the y is isolated in the first equation. I'm going to plug it in for y for the second. So I'm going to plug it in for y here. So I'm going to rewrite my problem. 4x minus 18 got plugged in. That equals 2 minus 6x. Well, there's really nothing to distribute. So I really can drop my parentheses and then solve this like a regular equation. So I'm going to go ahead and add 6x to both sides. I will end up with 10x minus 18 equals 2, because that cancels. I'm going to add 18 to both sides. So I get 10x equals 20. And then just finish your problem out, divide off 10. So I end up with x equaling 2. Okay, so remember, your answer is an ordered pair. So I got the 2 for the x coordinate. You're going to take 2, and I'm going to come back up here to the first equation and plug it in. Now, it doesn't matter which equation you plug it in for, but I'm going to go back to the first. So when I do that, I'm going to have y equals 4 times 2 minus 18. And then I just simplify. 4 times 2 is 8. 8 minus 18 is negative 10. So my solution to the system is 2, negative 10. Okay, let's move on to another. Solve by substitution. So this time the second equation is isolated. So I'm going to take the expression that is equal to y and replace y in the first equation. So I will have x minus, back up here. I'm going to have x minus 4, and then I'm going to plug in what y is equal to, 1/4 x plus 2, and then the rest of the equation says equals negative 8. Now, I do need to distribute here, and I am distributing a negative 4. So I'm going to have x. Negative 4 times 1/4 x is going to be negative 1x, or just negative x. Negative 4 times 2 would be negative 8. Okay, combine like terms. Well, x minus x is 0. So I really have 0 minus 8 equals negative 8, but 0 minus 8 is just negative 8. So when I get the same number equaling itself, that is our many solutions option. So when your variables drop out, it's either going to be no solution or many, and this is what many would look like in this case. All right, let's look at another. So again, you might want to pause the video, see how you do on this on your own, and then come back. All right, I'm going to take the expression for x, substitute it in place of x here. So I'm going to have 2, plug in what x is equal to, y plus 9. And then write the rest of the problem out. Minus y equals 3. Okay, I now need to distribute. So when I do the math, I'm going to have 2y plus 18. And then bring the rest down. Minus y equals 3. Combine like terms here. So I'm going to take 2y minus y, which is just 1y. So I'm going to have y plus 18. Is equal to 3. So now I can take away 18 from both sides. So I get y equals negative 15. All right, so remember, your answer is an ordered pair. I have the y coordinate done. I have a negative 15. So we're going to take that answer for y, and I'm going to plug it in for y in that very first equation. So that would be x equals the y value, negative 15 plus 9. And then we just need to add those together. So negative 15 plus 9 is a negative 6. So it looks like my ordered pair is negative 6, negative 15. All right, so I want to wrap this up with one application problem. So we're going to create two equations, and then we're going to solve them with our substitution method. Suppose a model airplane club publishes a newsletter. Expenses are 90 cents for printing and mailing each copy, plus $600 total for research and writing. The price of the newsletter is $1.50 per copy. How many copies of the newsletter must the club sell to break even? So how many copies of the newsletter? I'm trying to come up with the answer for how many copies. Now I went ahead and defined the variables for you. We're going to call X the number of copies, Y is the total cost. So I'm trying to figure out the value of X in this problem. Okay, so let's go ahead and set up our equations. So my first equation, I'm going to start with 90 cents for printing and mailing each copy. So I can write that as 90 cents for each copy. So I'm going to call that 90.90x. And then plus 600 total for research and writing. So I need to add in 600. That's going to give me the total cost. So I'm just going to set that equal to y. My second equation would be the price of the newsletter is $1.50 per copy. So the total price, so $1.50 per copy is also equal to the total cost. So I'm going to be able to take this and substitute. So I've got 1.5x equaling y. So I'm going to take that and plug it in for y in the first equation. So I'm going to have 0.90x plus 600 equals, and then I'm going to plug in the 1.5x. And now I'm ready to solve. So I'm going to collect x's on one side. So I'm going to take away 0.9x from both sides. Of course, that's going to add up to 0. So that'll give me 600, and then 1.5 minus 9 would be 0.6, so 0.6x. And then just continuing solving, divide by 0.6 on both sides. And so when you do 600 divided by 0.6, we end up with 1,000. Now, when I read my problem, it says how many copies of the newsletter must the club sell? And so that goes with the variable x. So I actually have the answer to my question. If the question went on to say what's the total cost, then I would continue. So I can go ahead and stop because I have my answer. So they had to sell 1,000 copies in order to break even. All right, if you need to go back and listen to any part of this, please rewind it. Otherwise, you may continue on with the assignment.